So today's lesson is about zero and negative exponents. And so we are just starting with exponents today. And those are the two types of exponents that we're going to be focused on. Now, if you want to get started with a warm-up, go ahead and solve. Or I'm going to skip this so that we can get right into the lesson. And by the end of this lesson, you should be able to say that I can simplify expressions involving zero and negative exponents. So to start us off today, we have some vocabulary to go over. And so the first word is exponent. And an exponent is a number that shows repeated multiplication. And so, an exponent is repeated multiplication. And then the base is a number that is multiplied repeatedly. And so if we look at this example down here, we have 4 to the 9th. Our base is 4, and our exponent is 9. So 4 is the number that we multiply repeatedly, and 9 is how many times we do that. And so down in expanded form, we can see what that would look like. An expanded form is an expression that shows your repeated multiplication. And so up in the top, our example of 4 to the 9th with an exponent and base is shown down here in the example in expanded form. Our base of 4 is repeated to that exponent 9 times. So we have 4 times itself 9 times. And so today we're going to look at two different properties of exponents. Our first one is 0 as an exponent. And so the definition is for every non-zero number a, the number a raised to the 0 power will always equal 1. And so remembering that anything to the 0 is 1 is very important for today. The other thing we're going to look at is negative exponent property. And so this is for every non-zero number a and integer n, a to the negative n equals 1 over a to the n. And so what happens if you have a negative exponent, you have to send it downstairs or down to the bottom of a fraction, and it will change your exponent to a positive. Now, looking at this chart, we have the 3 to the x, so we're going to focus on cube, 3 3s. Now, we have to take 3 cubed and write it in expanded form and then give an answer. So in expanded form, it'd be 3 times. Our base of 3 taken 3 times. 3 times 3 times 3 is 27. So go ahead and fill in the rest of the chart. Notice we're going to get 3 squared, 3 to the first, 3 to the 0. Then we're going to start going into 3 to the negative 1, 3 to the negative 2, and 3 to the negative 3. And so if you look at this chart, you'll notice some things. When I got to 3 to the 0 power, that means we're taking 3 0 times. So there's really nothing to write for expanded form. But I know also from our properties that it has to be 1. And then also when I got down into the negatives, 3 to the negative 1, I first wrote as 1 over 3. And same with 3 to the negative 2, 3 to the negative 3. And then once I had it in fraction form with positive exponents, I then expanded, and I found my answers to be 3 to the negative 1 is 1/3, 3 to the negative 2 is 1/9, and 3 to the negative 3 is 1/27. Notice the similarities that we have between positive exponents and negative exponents. 3 to the negative 3 is 1 over 27, while 3 to the third power is just 27. And so look at the similarities and differences that you see here. Now, moving forward, we have some examples that we have to think about. So, looking at this first one, we have negative 3 to the 0 power. Now, a lot of us are going to say, oh, it's raised to the 0 power, it's just going to be 1. However, that is not correct. Because what's actually here, remember that negative sign is actually a negative 1. So if we expand this, we have negative 1 times 3 to the 0 power, technically. I still agree 3 to the 0 is still just 1, but now we have negative 1 times 1. And so that's going to give us our final answer of actually being negative 1. Looking at the next one, 4m to the 0. 4 is just 4. And then m to the 0 becomes 1, because anything to the 0 power is 1. 4 times 1 is 4. And last but not least, this last one, we have 2 times a squared times b. However, anything to the 0 power is just 1. Our next examples deal with negatives. And so remember, we can't technically change it when it has a negative fraction or negative exponent. So what we need to do is we need to think of this as a fraction and we need to send it downstairs. And so we're going to take everything with that negative exponent and send it down to the bottom. So on the bottom, I'm going to have 2 to the positive 3. And because I took this away, the only thing remaining is just a 1 as a placeholder on top. From here I can simplify. 1 isn't going to change. And 2 cubed can simplify to 8. And so our answer would be 1 over 8. Looking at our next problem, we have 1 over 4 to the negative 2. 4 to the negative 2, it's negative. It needs to go to the opposite side. So we're going to send it upstairs this time. So we're going to have 4 to the positive 2 times that 1. And it's going to be all over 1. There's nothing left in the bottom. 4 squared is 16 times 1 is just 16 over 1. And so we can really think of it as simply 16 for our final answer. Here are some more examples to try on your own. Remember, think about what the exponent is grouped with. So a squared times b to the 0. A is squared, so that's going to stay a squared. Nothing changed. But b to the 0 technically becomes a 1. A squared times b to the times 1 is just a squared. At our next example, 2 over n to the negative 3. I see a negative exponent. It needs to become positive, so I'm going to send it upstairs. So I have 2 times n to the positive 3 this time. And if I take this away, there's nothing left in my denominator, so I don't need to worry about it. 2 times n cubed is just 2n cubed. And we can't combine them or simplify in any more ways. Couple more examples to try. Now we have a lot of pieces that are coming together. We have 2. We have an a to the 0 power. And we have b to the negative 2 power. Now, because we're just getting started, I want to focus only on one thing at a time. I personally like to make my exponents positive. So I'm going to bring up my b to the negative 2 to start. So I'm going to have 2 a to the 0 power and b to the positive 2. Because I took up this b, there's nothing left in my denominator, so I don't need to worry about making it a fraction anymore. So 2, I'm not going to touch. Next, I'm going to look at my 0. A to the 0 can become a 1. So I have 2 times 1 times b squared. And now all I can do is multiply my numbers. 2 times 1 is just 2. B squared won't change. And right there is my final answer. Now with our next example, we have 3a squared b to the negative 2 over c to the negative 4 d cubed. So looking at this, I'm going to make my exponents positive first. So I am going to bring up my c to the negative fourth power. So I'm going to have 3a squared b to the negative 2, c to the positive 4, and now because this d is still in the bottom, I have to put that all over d cubed still. I see I have another negative exponent, so I'm going to send that down. And I'm going to have 3a squared c to the 4 over my d cubed and that b to the positive 2. Now looking here, I have 3a squared c4. I cannot change or simplify in any way, and I have no negative exponents. And it's over d cubed b squared. They cannot combine, and they cannot simplify. I have no zero or negative exponents. So then that is going to be my final answer. And last but not least, 2 more examples. K to the negative 1 over 3n cubed, m to the 0, p squared. Remember I said I like to make my negative exponents positive first. So my k to the negative 1, I'm going to send down to the bottom. And remember, we always have a 1 placeholder on top, because when we take this away, there's nothing left on top. So we have a 1 as a placeholder on top, over 3n cubed, m to the 0, p squared, and k to the first power. And because it's to the first power, we don't technically need to write a 1. Now, looking through my exponents, I have no more negatives, but I do see that I have an m to the 0, which can become a 1. So I have 1 over 3 times 1, n cubed, p squared, k. And then that 3 times 1 is just 3. So it's 3, not 3. Still just 1 on top, over 3 n cubed, p squared, and k. And so right there is my final answer in its most simplified form. And last but not least, we have this last problem, 6a to the 4th, b to the 0, c to the negative 2, all over 3 times d times e to the negative 3. I like to make negative exponents positive, so I'm going to send that downstairs. So I have 6a to the 4, b to the 0, over 3, d, e to the negative 3, c to the positive 2. I have another negative exponent, so I'm going to send that upstairs. So I have 6a to the 4, b to the 0, e to the positive 3, over 3, d times c squared. Next, I have b to the 0, which can become a 1. So I have 6 times 1, a to the 4, e to the 3, over 3, d, c squared. And now if I look at my numbers, 6 times 1 is just 6. But I know 6 divided by 3 is 2. So I can think of this as 2a to the 4, e cubed, over d, c squared. And that would be my final answer in its most simplified form. If possible, you always want to simplify the numbers as much as possible.